On the dais, dear delegates, a very good morning to all of you. The topic of my talk is recent trends in distributed energy systems. And the key points I'll be covering in my presentation are about solar, storage, smart microgrids, DC microgrids, and 100% renewables. The traditional electric grids across the world is operating on a model of centralized power plants co-located with major sources of conventional fuels. They have large upfront cost, but of course the marginal cost declines with scale. The core principle of centralized model is that the power flows are in one direction. Additionally, it's easier to control and follows a social hierarchy. For all these reasons, the centralized market structure tends to drive market concentration. But because of the changing energy landscape, there are many now challenges for centralized power generation. The aging infrastructure, the high T&D losses. In addition to these cash losses, the electricity losses, they have an implicit cost in terms of greenhouse gas emissions. Then rural area is the last priority. The remote areas, the cost per unit of electricity becomes very high. In addition to that, we have new load types like electric vehicles, the rise of prosumers, rising energy demands, cyber attack risks. So all these are the drivers leading to embark onto a journey of distributed energy systems. Now, the distributed energy resources or the systems, they are small-scale power generation or storage technologies located at or close to the point of consumption. They have a fuel diversity, solar, wind, hydro, diesel, and they provide an alternative to or an enhancement of the traditional electric power devices. Now, because they are located near to the load, they reduce the T&D losses, they reduce the distribution congestion, they reduce the need for system strengthening, and they have an additional benefit of islanding and supplying the local areas in case of storms, cyclones, enabling power to be available even during the times of storms. So photovoltaics is by far the most important technologies for distributed generation of solar power. And the cost of PV cells, they have been decreasing. The solar PV modules have dropped about 75% in prices. Current scientific and technological advances in the laboratory suggests that they will soon be so cheap that the principal cost of going solar on a residential or commercial building will be installation. Now, whether to go in for centralized or the conventional plant or to the distributed, there's a break-even point. It depends. The cost of conventional energy is fixed for a fixed equipment lifetime. We have certain average cost. And for the distributed energy sources, especially the solar, depending upon the installation, well, there is a break-even point when the solar becomes cheaper. Now, despite all this, the penetration of electricity from renewable energy sources in capacity terms have been very minuscule in Indian context. The government target 100 gigawatt by 2020, and so far we have only 13.11 gigawatts in solar. Again, there are challenges, the limited dispatchability, the intermittency, the high variability. All this causes grid instability in terms of power frequency and control. And also, since the power conversion from DC to AC takes through power electronic devices, there are many issues regarding the power quality. But yes, storage comes to the rescue because it decouples the supply and demand. Now in the slide, it shows this variable supply, and we want to have stable demand. So whenever the supply is higher than the demand, we can store. We can charge the storage device, and during other times, it can be discharged. The things to decide on is when to charge, what source to charge from, how much to charge, and when to discharge, how much to discharge, and what load to discharge to. So there's a troublesome coupling. There are different storage technologies, different sizes available, and for different applications they are required. We need to decide upon the cost, what are the battery parameters required, what are the performance targets we need to get. So hybrid energy storage, again, one choice is we have different devices, storage devices, having different energy densities and power densities. In addition to these storage devices, now we have new battery technologies like sodium-sulfur, plug-in hybrid vehicles, which can be operated either in G2V or V2G mode, can be used for peak load leveling. And again, at different points of the grid, we can have storage, bulk storage, 500 megawatt above, substation, 10 megawatt, or at residential up to 100 kilowatts, and so on. So incorporating solar energy and storage in the power sector requires infrastructural changes and new ways of managing the power in the grid. So Dr. Ganesh Das talked about the smart grid, different smart grid technologies, how the digitization, the two-way communication, the automatic operation can be incorporated using these technologies. Microgrids, they are a critical component of smart grid. They are an ideal way to integrate renewable resources on the community level and allow for customer participation in the electricity enterprise. They form the building block of the smart grid. And they also make the system more efficient and modular. We can also have a DC microgrid. A DC microgrid comprises of a DC power generation source like fuel cell, solar PV panels, or micro wind turbines. A DC electrical source storage like battery or a supercapacitor, DC distribution, DC gadgets, laptops, telephones, DC lighting. Now, while homes generally require an AC supply for inherently high power devices such as washing machines, there are surprisingly number of environments where these devices are not used. In such cases, a DC microgrid could be the sole power provider. The elimination of inverter cost, simplified installation, and reduced fuel cost yields a DC microgrid system which is very cost effective and can operate independently of the electricity grid and conventional main power. Also because it operates at low voltage, so there is low danger of electric shocks, and it makes plug and play grids a possibility. And adding intelligence and internet connectivity to DC microgrid controller would enable further customer engagement. They have not yet found a wider application because of higher electrical losses associated with transmitting a fixed amount of power as low voltage DC rather than higher voltage AC. But with the proliferation of low power electronic devices, bringing the potential for LEDs to reduce lighting loads by up to a factor of 10, and the potential for efficient distributed power generation, localized DC networks, or microgrids may finally be practical.
Madam, only 1 minute,
yes,
please.
100% renewables, a very much debated topic. Some researchers say that since solar and wind are variable, we don't know whether the sun is going to shine or whether wind is going to blow. We need to make, or the grid does need coal. But Petrogonis says that this is doable. Many countries have committed to 100% renewables. The line of action can be that we can continue to build new solar, wind, and hydroelectric facilities at a rate faster than the fastest single-year rate Germany achieved in the energy. Germany, because they have the best practices in solar. Then, construct a vast amount of energy storage with an output capacity comparable with the entire current electrical system in the country, nearly all of which consisting of technologies that do not yet exist today at commercial scale and for which there is no reliable cost information. And also, We should be able to reschedule industrial energy demands with an 8-hour window around. Maybe then it's possible. So I'll say that smart grids are only a means to an end, which include not just sustainability, but also efficiency, robustness, energy security, etc. So smart systems are more than adding technologies just as smart meters and solar panels. They represent a transformation along the ecosystem of stakeholders and their incentives. 100% renewable energy is not just a fantasy for someday, but a reality today. Each of us is part of the problem of dependence on conventional fuels and their harmful impact on the current and future generations. Each of us can also be a part of the solution. Let's do it.